So we're here to talk a little bit about advanced analytics, also known as TwinThread. And we're going to try to dive in a little bit and show you a bit of why advanced analytics is a great solution and a little bit how easy it is to get to what I would call a pragmatic AI approach and something that everybody, especially in operations, can use. So your presenters here, myself, John Baier. I run our Lighthouse Early Adopter Program, VP of Customer Engagement. And we have Fabio, Dani, who is one of the key R&D engineers that runs Lighthouse projects with us. Anyway, let's get into a little bit about digital twins and TwinThread. So we're going to do a little bit of advanced analytics overview. And then we'll get into a specific model in advanced analytics called Perfect Centerline. And it's a very useful model. And Fabio is going to go through and give you a quick run through of how easy it is to create a perfect centerline solution. So I think everybody's seen some of these big overview slides. In Connect, we have our data layer, data and contextualization, Connect Data Services, our new industrial knowledge graph for context. We have our visualization layer for visualizing, and we'll show you a little bit about that. And then we have analytics, our analytics layer. And until recently, that's been one of the areas that we don't have as much going on. And now, of course, you heard, hopefully you all heard by now. Next slide. I can't say more than this. I was told I can't say more than this, so good luck reading it. But basically, yay, we bought TwinThread. So I'll give that a hand. Subject to regulatory approval. And so we're really happy to have TwinThread on board. And I'm not allowed to say anything more than that, but sorry. But we're going to show you TwinThread in action. It is also AKA, it's got an analog twin called Advanced Analytics. And basically, the TwinThread solution or Advanced Analytics solution has three main pillars around it. One is being able to provide calculations, first principle models using those calculations, something called the thread engine. And then alerts and recommendations. So when things go awry or a model detects an anomaly, being able to alert individuals, people. Most of the models that are really used that we see out in the wild are around this process optimization. So optimizing processes for building better quality products, and you'll see that as perfect quality, being able to monitor and affect batch operations, perfect batch, and then this perfect centerline, which is really around building a application similar to batch around multiple objectives that you're going after in a manufacturing plant, but finding that golden run, the best run you've ever had, and trying to run every run like that. And ultimately, that's kind of what we're all going for. There's also some really great analytics around assets and asset optimization, asset uptime, remaining useful life, and just plain anomaly detection. All of that is backed by a thread engine, as I said, a digital twin model that basically allows you to model your data, your assets and your processes, and a model factory around building new models. Integrated highly with Connect. So it's integrated directly with Connect Data Services, and it's integrated directly now with Connect Visualization Services. So it's really become part of the Connect suite, if you will. Next slide. So the idea behind advanced analytics is automating your processes. So the first thing is establishing a baseline. Here's how my process runs or my asset runs. Doing some basic anomaly detection. So TwinThread and advanced analytics goes off of old data. It goes off of history of your data. So you've got to kind of collect data to be able to understand what it looks like. And then the next piece is really looking at what are the things affecting my process model or my asset model. So the top drivers. And TwinThread does a great job of bringing analytic to the end user, to the OT user, using some built-in user interface, and shows you how your data is performing, how your models are performing, and allows you to understand that at a deep level. You don't have to build it, it comes to you. And then finally, once you understand how your model's running and you can say, this is what a perfect run looks like, putting it into operation and letting it run autonomously. So really nice steps towards automating, getting your best manufacturing runs. Next. So again, the big models here are around process optimization. I mentioned quality, I mentioned batch. Perfect energy is another one for energy monitoring, and then we have all the asset optimizations as well. So throughput around assets, asset reliability, and remaining asset life. What we're going to cover here in the demo is something called Perfect Centerline, as I said earlier. And Perfect Centerline is really very similar to the batch model, but it is taking any manufacturing process, taking a baseline of what is that centerline, what is the best run, and then helping customers react to the current manufacturing runs and making as close to that center line as possible. So with that, this is really used in all kinds of applications, consumer packaged goods, food and beverage, chemical industry, pharmaceutical. One of the things that distinguishes Perfect Centerline and batch are really that they have multiple KPIs or multiple endpoint goals that you're shooting for. And you'll see in the demo where we shoot for things like reducing downtime, but also getting the highest yield, or getting the highest yield and using the least amount of energy to do so. So having multiple objectives that we're going after. And sounds like these things don't work well together, but they do. There is a way to find the best balance between these objectives. So with that, we're going to first walk you through 4 big steps in the process. And Fabio, why don't you take us through the first one?
Sure. So yeah, the first thing is let's go ahead and create our twin. Basically, you have our source. You choose the source of your data. You can create multiple sources, different sources. You choose the hierarchy that you want to create and create all properties, create twins, and the tool is going to create for you the twin itself and is going to associate all the data into the properties. So I'm going to check my twin, and let me pause here for a moment. Here I'm going to show the sensors or the values or the variables that you have in your process that are connected already to your twin. I'm going to segment by product. So this is a very nice wizard. And by segmenting by product, I'm telling the twin, what am I producing? It's one product, it's multiple products, and just based on a specific stream of data, we can say which products we are producing. Next step is going to be the segmentation. So how am I running, am I stopped, and am I in downtime, and things like that. So I'm just doing that because this is going to go a bit fast. So this is all my data. It already got the data from the source. I'm going to segment it by product. So yes, I'm producing multiple products. I'm selecting my product stream. And I'm going to create an event type. So I'm going to create events for this product. I can use something already pre-made, or in this case, I'm creating a new one. So basically, I'm telling the twin, okay, these are my products. Just create them for me. And this all goes through this nice wizard and makes your life very, very easy. Next one is the operational states. Kind of the same idea. I'm just going to look for my state stream, and I'm going to create the events for it. Same idea. It will create events for me for the whole time period I'll train the model. And now it is going to evaluate the values, so down, running, or starting up. And I just complete it. And as soon as I close this, there are background tasks that are creating the threads for me. So I do not need to create them myself. The tool actually gives me some help on it. And this is the system-created thread, so it is just getting that stream and transforming them in events. I also have a calculation for my yield that is going to be my KPI in the next step. And this is just a logic that it is giving me some yield at the end. The next step is my downtime. This is, again, some logic that I created. If you have a stream or a tag that has this information for you, you just use it. In my case, I'm just creating it here with some calculation. And I'm done. My twin is pre-made, it's created, and is waiting for my next step, that is to actually create my model.
So your two big objectives here are yield
and downtime.
Downtime.
So I'm going to tell the model itself what I want from those two objectives, because so far for us it makes sense, yield and downtime, but for the model it doesn't. So I'm going to inform the model now what to do. All right. So starting from here, I'm going to create my perfect centerline model. I'm calling it Perfect Centerline. Not very creative, but it works. And it's going to bring me to another wizard, that is the wizard to create my model. And I'll start adding the data. So let me just pause here for a moment. After I click, I just want to bring my first KPI here, and I'll go from there. So just drag and drop my yield. And in here, what I want here is to inform the model what I want to do. So one very cool thing is that we can put a monetary value for that KPI, sorry. And the model is going to try to tell me, if I follow my best center line, how much can I gain in the future? So even if you're configuring this and you do not know exactly that value, plug a number in there. So then the model can actually try to help you understand what's going on. And moving on, my target, of course, for yield is maximize. Here I'm entering a value, as I explained before, just how much I can gain per unit per year if my model is the best it can be. Next one is going to be my downtime. And my downtime, in this case, of course, I want to minimize it. And as soon as I minimize my downtime, I'm going to enter another monetary value for it. And what is interesting is I can actually weight those two objectives against each other. And you are going to see that in a moment. I can give weight. So which one is more important? Which one makes more sense for me to maximize against the other or minimize? So you can weight them as you want. Okay? Inputs. So I'm going to just drag a bunch of values into my model, and now let it decide. The tool is going to tell me the bigger drivers, and it is going to decide which ones to use, which ones are more relevant, which ones are not. Okay? So if you're not sure, put a little bit more, and the model is going to take care of the rest. Let me pause this here for a moment. Remember I created my product earlier? So it already understands that it belongs to the twin. So it understands that this is my product segmentation, so it already put it here for me. I don't need to touch anything. It understands that. Same thing is going to be for the filtering parameter later on. It understands that my states are this, so it's going to drag it for me. So I don't need to touch anything. And at this point, my model is configured. It has the data. I'm going to set the timing, so how much data I want to do in my training, and how fast I want this data to be collected from my data source. I put 15 minutes, and this is going to pre-evaluate the model. So there is this configuration check just to make sure everything seems in the right places. and I'm going to evaluate my model. This can take some time. This is some sort of pre-training that it does to see if my data is fine, if there are gaps or things like that. And after some time, what happens is it gets very nerdy about your data. It shows you a bunch of things, like data-wise, standard deviations, averages, and all that kind of stuff. You can get very happy looking at this data. Next one, it starts giving me some idea of how much gain I can have. And this is like a pre-run that it made. So it starts giving you some values, some annual values, how much ROI you can have based on the numbers we inputted earlier and based on the data. Some more like geeky informations. And yeah, your model is pre-trained. So at this point, we can actually go ahead and do the actual training. And I'm training for 30 days. It can be more, it can be less. Usually, the more, the better, kind of. And as soon as I launch that, in the back, there are tasks that are running. It can take some time, depending on how much data you have. And back from the training, I'm operationalizing the model. Of course, this is usually, you analyze the results first, but I'm just showing the operationalization of my model. I'm making it time-based. So every 15 minutes, it gets more data. You can, this is running every 15 minutes, getting a refresh. You can configure recommendations. So startup recommendations, running recommendations, as many as you want. I'm just putting a handful here, creating these properties, and it is going to recommend these properties for me. There is a bunch of other parameters that you can like fine-tune the model, tweak here and there, of course, in a later phase of your project. There are benefit tracking and another like drive actions and things like that. But what is interesting is you can set up alerts. If your model deviates a bit, if your process deviates a bit from what the model thinks, it will send you a message and say, well, something went wrong. So quite interesting. And yeah, we are ready with our model.
So you just covered a whole set of work that if you were a data scientist working in Databricks or doesn't matter which platform in Python, that could have taken you days.
Yes.
Many days to do all of those steps to get your data, clean it,
Yes.
train it, look at the results, evaluate whether you've got everything you need, and understand whether it's going to bring you any value. And you just did that with no code in walking through a few wizards.
Yes.
I think that's pretty cool. And so those recommendations, those are for recommendations that come back to the operators of the system so that they know that there's things that they can change? What is that?
There are things they can change. You can give them back to the operator. The operator can look even here or somewhere else, like in your Pi system, even in a CVS screen, the recommendations that the model gives to you, and start moving from there.
Okay, great. So, and hopefully we'll see this later, right? Where we bring the recommendations to the operator through a Connect visualization.
Yes, we are going to see that.
All right, well, let's get into analyzing the results of the model and see how it's running.
Yeah. So basically, we did all that work, but what we want is results, right? We want to see what this tool can show us and what it can do. So now I'm going to walk a little bit through the results. So artifacts, I'm basically now going to look what the model gave me. So that is somewhat the same screen that we saw before, but now with the full training, with the full algorithm running and giving me the results. I can drill down a little bit more if I want more information. So it is going to go ahead and show me about this specific KPI, what it found, what can I gain, how much can I gain, how many units I can gain if I run in this, like if I had run all my runs perfectly as it found. It shows me the top model drivers. So what were the variables that influenced the most my model? As I said before, I sent a bunch of data, and the model now, the tool is telling me, okay, this is what influences the most your model. Ideal running conditions, so what are my running conditions specifically for the data that I sent it? Maximums, minimums, which is the current value for the process. some centerline report, so how it is doing, and it segments by product, and it is telling me my targets, my lows, my heights, and is telling which one is a bit high, which one is not so ideal. You can look at your last runs, so you can see what you have been doing with the process. Some centerline conditions, so in a general way, like in one screen you can see like a picture of how your process went. Some anomaly history, so what were the anomalies it found in your process? So like small things that happened you didn't even notice. You can break it down to some very cool statistics about where it went wrong, what it is trying it was trying to accomplish something, it couldn't, and where exactly are these anomalies. So all very interesting and very visual. You can see what's happening in your process. The other one that I like a lot, that I'm going to show here, is the center lines. So basically, the center lines are, this is what the tool found as the best run. Okay, so it is going to put that in your left. This blue is the perfect center line. You can set the criticality. Let me pause for a moment. You can set, the model found it is high, but if you say, no, this is a critical variable for me, like forget what you're saying, I'm saying it is critical. So you tell the model it is critical. You tell the tool it is critical. So you just put your own will onto his.
So Fabio, part of this is, as a process engineer,
yes,
you're looking at this data and you're going, some of this doesn't pass the eye test for me. You can make adjustments to it. It's not just blindly following an AI model. It's using your own intelligence about your process and your implementation, your factory,
yes,
to help you make some good decisions here.
You are you are in the plant every day. The model is there for a few minutes, so you'll know better.
Yes.
You can also say that the model, next time it trains, it overrides those values, but if you put a value in there, you just lock it, and you say, don't change this, and the model will not change it, okay? So it's not only that it helps you, it also you can also tell it, okay, follow my lead, and just, your job is to help me. And if you decide that another run is better, you just override that one that the model found. So you say, no, this is a better one for whatever reason, you just tell it, okay, use this one and forget what you just found.
So this is where it's similar to golden batch, right?
Exactly.
Or what people think about as golden batch. You find your golden, hey, this is the best, everything is run perfectly at this time. I want them to all get as close to that as possible.
Yeah. And my last step is to visualize it in the dashboard. Like John was saying, you want this data to be available to everyone. The more people looking, the more value it has. So the idea here is going to be, let's get some of this data into Connect visualization. And with our new, no, this is the right one, sorry. Yeah, with our new widget tool in Connect visualization, we can actually embed what we are seeing here in Connect visualization. So if you are the data scientist, you did all this cool thing in advanced analytics, and you want to show this to another person, like in your plant, they don't need to have access to your advanced analytics. We can embed this data into Connect visualization. We put the web widget, we copy the URL in there, and coming back here, you paste the URL, and it will show you the content from Advanced Analytics into your Connect visualization. So you can also combine this data with your Connect data in here. So I'm just going to put my model, my drivers there as well, but I could have potentially added more like widgets and gauges just to combine the data from the analytics with the data of your process that is currently running. So this is pretty cool to have those two views together. And yeah, this is just me adding another one. My OCD got bad there, that I needed to make it perfect size. And yeah, and that's pretty much it. Now you just save it and you move from there.
All right, cool. So recommendations, as it's running, as your model's running, back to the operators. we've certainly also seen, in addition to Connect visualization, those drivers or those ideal running conditions coming back to operators in a, in-touch HMI. We've seen driven that way, and also to Pi Vision. So, and this is really valuable as well for the people actually on the floor to see, hey, there's this cloud-based model, and it's giving me recommendations about how the process is running. Really pretty powerful. So a couple success stories here. Voestalpine. Now, typically we talk about, hey, go see this talk. Well, these have all happened in the last couple days. So I'll say maybe you can go see, and these talks will get posted up on our website after the conference. You can go watch this if you didn't get a chance to check it. Voestalpine Krems is a steel manufacturer. They do rolled steel. They used advanced analytics for two basic analytics. One was on cutting the rolled steel. And Fabio, I know you worked on this, so maybe you can talk a little bit about the two.
Yeah, sure. So one of the cases was to cut steel tubes, and the idea is that the saw that does that cutting, it wears down. So it starts to have some quality issues when the saw is not as good. And then we were able to actually monitor the saw wearing, and you can actually see in a trend when the saw is getting bad.
Yeah.
So, and it opened a door for them. They said that in their talk yesterday, that now they are able to test different material combinations, so a different saw with a different tube that they're cutting. And they will be able to actually tell which one is better to cut like specific product. So it opened a door for them that they didn't know it would be there. Right. So they're able to do that now.
And they also improve quality, right? Because if the saw is going bad, it leaves burrs and defects in the rolled steel. So not only are you saving money on, hopefully, the saw before it fails, but also on potentially cuts that maybe were not ideal if the saw blade gets dull.
Exactly. Yeah. So very interesting project. And
great project, and a great story if you want to go watch that one. And one more, Lamberti, and Hans Otto's right here, and he's worked on both of these as well. Hans Otto, and we worked with Lamberti recently, and this is a Italian company to do, and this is really golden batch analysis. So they're using the perfect batch advanced analytics application to watch basically every batch and run it to a golden batch standard. This is also, they're one of the first customers to really use our new Connect model, including our industrial knowledge graph. So achieving 5% energy reduction and improved uptime with this whole thing. So two really good use cases. We have many more with advanced analytics. This, I guess, in closing, maybe we could go to the last. In closing, look, this is a product that is bringing AI to people who are not data scientists. It's really meant for process engineers, for OT engineers to be able to experience AI without having to write code. So point and click environment, pretty easy to do. It does take some iteration to learn how the models work and to see how your model's running and tweak stuff, but worth it at the end because you can really see some huge savings. So with that, I think thanks for your attention.
Thank you.